Hey, hi, this is your instructor Maliha, and today I'm going to be discussing the simplex method with you. This is going to be basically based on the maximization issues that we can have for linear programming. And why am I immediately starting with simplex method is because I wish that we can immediately grasp something which is more defining, has certain complexities. Then we can go towards the easier concepts in a short span of time, which include the feasibility region and constraint optimization. This might progress to the second week of this lecture. So let's just begin with the simplex method of attempting the linear programming. And the easiest way is to just simply go on to the question. So I'll be reading the question, and then we'll be switching on to the board so that I can I've just written the summarization of this question, so you can easily refer back to it. Now this question is that Acme Baby Foods makes two puddings, vanilla and chocolate. So basically we have to consider making constraints in the variables of x, y, and then we can have certain other variables which are introduced with the main variables, which are known as the slack variables. So now two puddings, one could be x and the other could be y. Each serving of vanilla pudding requires 2 teaspoons of sugar and 25 fluid ounces of water. And each serving of chocolate pudding requires 3 teaspoons of sugar and 15 fluid ounces of water. So class, you have to make sure that whatever composition and combinations are given to you, you have to summarize them and group them under a certain variable, and you can't mix these two together. Acme has available each day 3600 teaspoons of sugar. So now this becomes a constraint. Now, what is a constraint? It's basically some kind of a restriction on you that she cannot exceed these teaspoons. Whatever amount is given to her, she has to make use of that. 22,500 fluid ounces of water. Acme makes no more than 600 servings. So this is another constraint now. So now we have 3 constraints here. First is that it is available, for not more than 3,600 teaspoons. The other says that it is, it requires, or it is dependent upon, maximum 22,500 fluid ounces of water, because we're considering maximization problems at this time. Therefore, we can't exceed the values which are given to us. Now, Acme makes no more than 600 servings. So that is the maximum amount of serving that she can make out of the pudding, because that is all that it can sell each day. If Acme makes a profit of 10 cents on each serving of vanilla, so now we have to associate 10 cents with vanilla and 7 cents on each serving of chocolate. And 7 cents we have to associate with chocolate. How many servings of each should it make to maximize its profit? Now we have to ensure that the servings that we have to make refer to the variables that we have, and then we figure out what is the value of P, which is the constraint maximization. Now we refer to the board. Let's you can always rewind back to the section if you don't remember the question. I have summarized the details for you so that you can see here that Acme Baby Food makes 2 puddings vanilla, so 2 teaspoons sugar. So now, as I said, that we have to make one a constraint with variable x and one constraint where only we'll be considering variable y and keep x as 0. So we will basically be having x and y coordinates within one constraint, and in the second one we will be having again another value of x with chocolate, and then we can have another one with fluid. So let's just start making the constraints. So first of all, we have, okay, now in the question there was another issue concerning the maximum value that they can probably produce of servings. So I would like to keep this in the first, because it's just single constraint where x can be less than, or let me just put it towards the side, that because we'll be requiring this explanation, that x is, or it has to be less than or equal to 600, because now this constraint restricts the servings of vanilla. So now, since it is vanilla and we are considering that X is actually vanilla servings, and Y can actually be, or let me use, Y is chocolate servings. Okay, so now that is why we basically term that in or refer to it in terms of X. Now, the next part of the equation we have to make from the information that is given to us of 2 teaspoons of sugar, and this is X. So 2 of X, because we have already said that vanilla servings refers to X. So for vanilla pudding we require 2 teaspoons of sugar, and for servings, and we have similarly 3 teaspoons of sugar for chocolate. 3 teaspoons, like I said, this Y is for chocolate servings, so 3 of Y in this case. And now it states that the sugar teaspoon that she can use is perhaps not more than 3,600 servings or teaspoons. And then we come back to the water part, because now it also requires, the recipe requires that we need fluid in ounces. So 25 fluid ounces for vanilla. Since we're doing for X, so we have 25 for vanilla, and we have 15 fluid ounces of water for chocolate pudding. And then again we have to put this less than or equal to, because we are constrained towards the ounces that we have, or in this case we have the water the volume of water that we have is, it could be in liters or ounces, whatever, but the part is that this is constrained towards this 22,500 value of fluid ounces of water. Now, do remember that this equation can be simplified. If any equation out of these equations can be simplified, then you have to simplify them. So for this, now we can just simply divide by 5, So dividing by 5, what we get is 5x plus 3y less than or equal to, so now 5 4s are 20, and then you simply divide it by 5 and you get about 4,000, and 5 5s are 25, so it's 4,500 units. Okay, now this is a constraint where we have to convert this into equality. So if it is less than or equal to a certain value, that means that we have to add something to make it at least equal to this, right? So now for the first one, we can have x plus some variable s that can equate it to 600. Now why have we done this? Because x is less than 600, we say, or it could be equal to it, provided that there's no other variable. But since we say that x is less than 600, that means that if I add something to x, it could become equal to 600. And then we can apply the similar logic for all the other constraints. Then, therefore, it means that's 2x, and I can just put it in a distance. 2x plus 3y plus t is equal to 3,600. Similarly, 5x plus, again we have 3y so let me just confirm that we have the same value, 3 teaspoons. Okay, now this is 3y plus u, another variable, comes to about 4,500. Now, okay, so now the third, and we can just number these equations as 1, 2, 3, and in the last, we are given a profit constraint. The profit maximization says that we are given 10 cents for vanilla serving and 7 cents for chocolate serving, so that would maximize our profit. Therefore, we can just simply state that this function initially could have been written as profit is equal to 10 of x plus 7 of y. Okay? So therefore, we can just bring it to the other side, because now we want that the slack variable should be toward this side. Therefore, now minus 10x minus 7y, okay, and plus p, because we are bringing it towards the other side, is equal to 0. So we equate it to 0, because if this is equal to this and we bring it to the other side, then this whole equation will be equal to 0. Okay, so now we have our constraints in order. Now we can, start with the tableau and the simplex method to find out. Let me just get the data is correct. Now we are going to be converting to the table this whole value. Okay, do you remember this, that these variables are known as the slack variables. Slack variables. Right? And these are the normal, variables with which we can form the constraints. Okay, so now first of all, I have to delete this after some time. So I just made the table here. Or maybe I can just delete this question in order to have some more space with us. Okay. How do you fit it into constraints? So first of all, we have an x. We have an x. We have a y. Then we have the slack variables as s, t, u, p. Okay. Now we draw it to the other side. These variables again we hash them here in a transposed form, s, t, u, but we are going to be, now since p is constraint for profit, we're going to be keeping it a bit separate here, because this is towards the other side of the constraint, and we need to find out what is the profit after figuring out what are the values of every variable. I'm talking about x and y if we can, or if we require, as per the conditions that have been given to us in the question. Now let's just assume that in the first x is less than, so x plus s is equal to 600 in this case. So now x is 1, and we can assume that this is 0, because there is no y here, but we have an s as 1, and we have 0, and this is equal to 600. Okay, we just extend the line. Okay. Now then, again for the second part, we have 2x and we have 3y, and we have 0s here, but we have 1t, and we have 0u, 0p, and this comes to about 3,600. And the third stance, we have 5 of x, 3 of y, and we have 0s, 0t, but we have 1u and 0p. So we are going to be zeroing all the other slack variables which are not present in our equation. That's why I've left the gap, as you can see. This comes to 4,500. Now, about P, we have negative minus 10. We have minus 7 as Y. But we don't have all these slack variables except P. So now this is 1 in this case. Notice that this sort of forms a diagonal pattern like this, I guess this is a dotted line. Just follow this pattern. And this comes to about equal to 0, like our equation says. Now we are going to be doing some operation on this table so that when we make the new one, the objective is to convert the variables which have negative value into positive value, or remove this value and convert it into 0, because we don't want this negative. So while we don't want the negative, we would rather have the 0 one. Okay, so if we have to convert it into 0, that means we need to find one main variable with which we can perform this operation. So in this case, we have to find a pivot, column. A pivot is like a pivotal column with which we can perform the operation. For that, we need to find a test ratio. We need to do a test ratio. So this is a test ratio, and for pivot column, P-I-V-O-T, pivot column. So how do you do the test ratio to find out what's the pivot column? For this, if you see which variable, when you can put it in the denominator, can give you the lowest ratio. In this case, if you divide 4,500 by, let's say, okay, first of all, we need to see what is the maximum value of the negative that we can have in this. I'm not talking about the value as in whether it is in real terms greater or not, because in real terms we know that minus 7 is greater than minus 10, but which is the heavier in terms of the negativity. So, or the negative sign is with the greater value, which is 10. So we are going to be considering this column, and we are going to be subtracting the value such that it gives us 0. And performing the operation for this column means that we need to find the test ratio for this column. And for 4,500 divided by 5 will not, it will give you something around 900. It's not going to give you the lowest test ratio. 36 by 2 will give you something to the amount of maybe, it will give you 2 and 2800 something. And then obviously, this is not going to be the same as this. Now, when you, or it's going to be, sorry, 1800 something. And this is, if you see 600, so this is basically 9, it's going to be 18, and this is going to be the same, because this is 600 divided by 1. So, for the first part, 4,500 divided by 5 actually gives you 900. And 3,600 divided by 2 would give you 1,800. And 600 divided by 1 would give you 600. So we are going to be accepting this because this gives us the lowest ratio. So our pivot value would be 1 in this case. So we are going to be performing the operation and writing it towards the right hand side. I'm going to be rubbing the calculation. Okay. Now, if you see that performing the operation, we need to subtract something from, so we can just simply write row 1, row 2, row 3, and row 4. So now, subtracting something from row 4 that can make this as 0, because we need to have this entire column except for the pivot row. Except for the pivot row, which will remain untouched. The remaining values of the column will change and have to be converted to 0. For every value For row 2, 3, and 4, we have to have a 0 in that column x. So performing the operation means that R4 minus or plus, in this case because we already have a negative value, so 10R1. This is the first operation. Because when we add 10 to this, it becomes 0, right? Next, what can we put here so that when we subtract from the pivot or the main vital row column, that when performs the function on this, it converts it into 0. So this is R3, which is and we have minus 5R1 in this case, right? Because when you multiply 5 with row 1, then you can subtract it and you get 0 out of this. Then we have again R2 minus 2R1, because then you can obviously get 0. So now we rewrite this again as, we can just make it again x, y, s, t, u, p. And always remember that the row which is performing operation on other rows remains the same, but we are going to be extending the operation here, and the value of this will change because this will be now the exiting variable. Exiting variable. Exiting means basically that we are going to be ousting this and replacing it with the value of x. So in this case, this row 1 will become as x, row 2 will be t, row 3 will be u, and row 4 will be p. Okay. So row 4, p. So now performing the operation R4 plus 10R1, we write this as just the way we have written before. This is 1, 0, 1, 0, 0, and 0. Now this comes to 0 because minus 10 plus 10R1 is 0. Again, minus 10 plus 0 will give us minus 7. 0 plus 10R1 will give us 10. Right? Because see, this is R4 is 0 into 10R1, which is 10 into 1 is 10. So we put 10 here. Okay. Next, okay, I'm just going to be drawing lines so that there are no confusions here. Excuse me, please. Okay, we have, the next is again, we have 0 and we subtract or add, in this case we add, when we multiply with 0, so you get 0. Again you get 0 here, and we have R4 plus 0, so we have 1. So remaining values almost remain the same. Now performing the operation on this one, so this is row 3, this will give you 0 because it's 5 minus 5. So you have 0, 3, minus 0 will be 3, and this will be automatically 3 as well. Then we have 0 minus 0 will be, okay, no, s. Okay, so now this is 0 minus 5. This will be minus 5. And since it's 0, so minus 2. So we can have minus 2R1. So this is obviously minus 2. If something is easy to write, just write it straight off. Then we have the t column, the kth column, 0 minus 0, you have 0 here. But for 1 minus 2, so you have 1 here because this is R2, this is R3, and R3 is 0, so minus 0 you get 0. But for R2 you have 1 minus 0 because this is 2 R1, so this is 0, so you get 1 here. And naturally the other values will remain the same because you have 1 here, so this is R3 minus 0, and you have 0 minus 0. Again, you have the same and you copy them as it is. So now we're left with this value, which is R2 minus 2R1. So this is 2R1. Again, this is 0. That is what our primary motive was, to keep all the other values except for the values that are given in the pivot column as 0. Now we have to redraw and put conditions because now we have another negative here. And we have to finish this negative like we finished this negative. Therefore, we are going to be drawing another table. And let me just draw another table here because lack of space. So we have now, this is the third table. Okay, this is the third part. This is the second. I'm just going to be numbering them so to allay any confusion. Now we have row 1 as, okay, so I have to also write down the function, so let me just I have to complete this column as well. So this, since this was the pivot column, we can write the 600 as it is, but if you see that this is R2, and since we have done operation on all the values in the row R2, we have to subtract 1200 from this, right? Because as you can see that this is minus 2, so this is 1200. So when you multiply minus 2 with this, is going to be 3600 minus 1200. So it comes to about 2400. Then we have again 45, this is R3 minus 5R1. So now we have 45 minus 5 and 6 is 3000. So we have 1500 here. And then since this was 10R1, so this is 6000. Now our row is complete. I need further space because the reason is because I have to write down the operation that I'm going to be doing next. Let me just see, maybe I have to, wipe this away. Okay, so what operation now can I perform that I can make this as 0? So now, let's just say that I need to find out what is the test ratio. Again, we have to repeat the entire procedure again. If you see that I consider that column which has a negative value first of all, just like you consider this as having the negative value. Then I see which has now, okay, this is tricky part because we have two values, above and below which are the same. So which I take now? So the one which will give me the lowest ratio, the lowest test ratio in this case. So naturally this will give me, so that this becomes a pivot column. So now this will be written the same. Now I have to perform operation on this one. So what operation can I perform? Okay, again I write as this is X, Y, S, T, U and P. So now I remove these for the time being, or maybe I can just adjust them a bit. S, Y, S, T, U, and P. And we have, okay, so now there is another thing that we need to see, that since we had one variable departed, now we are going to be using another variable. Since this is the pivot, row as well, then we are going to be removing this and converting it into y. So now the first row would be R1 X, and this is 1, 0, or maybe I can perform the operation directly. So let me just write that later. Let me just begin by understanding that since I'm going to be performing an operation on this, so I am going to be writing this row 4, and I have to add something to it. So, and I multiply first of all 3 with this, because I have to make something common so that it can be subtracted, from some value, or some value can be added to it. And plus 7 into R3. As you can see, this is minus 21 and this becomes plus 21. So then this will become 0. And for this, I only need to subtract from R2, R1, right? And for this, I don't need to perform any operation. This will be written as it is. So I need to perform only on 2, rows at this time. Now I have to make some space. Let me just see. I have to unfortunately rub this, okay, to make way for the new table. Again, we have the same X, Y, S, T, U, and P. And now this was row 1, and this was X. And since we are going to be starting from the lowest row, so let us just perform the operation also 3 R4. So in this case, this will be 0, 3 into 0, R4 plus 7, R3. And this will be 0, so this remains the same. So now in this case, R4 would remain the same. Okay. Something like I have to just make some adjustments. 7 R3. Pause कर Resume. So now R4 will be 0. This is X. This is row 2. This is T. Row 3 would be Y in this case, and U would be the exiting variable that is going to be the exiting slap variable. Let me just write down the whole values. And this is P value. For R3 it's 0, 3, minus 5, 0, 1, and 0. Now this is 1500. Okay. So this is the first one was 0 because 0 minus or plus 0 gives you the same, doesn't change anything. Minus 7 into 3 is minus 21, 3 into 7 is plus 21, So in this case, it's going to give you 0. Next we have 10, so 30 minus, so now this is 30 and this is going to be 7 5s are 35, so minus 35. So 30 minus 35 in this case is going to be minus 5. Minus 5. And the next value will be 0 because you can't really add or subtract with 0. And then we have next again 0, but we have a value of 7 here. Since this is 3 into 0 plus 7, so we have 7 here, and 3 again we have as so we're just going to be having 3, and anything multiplied with 0 would be again null, so we have 3. And then this whole row would be again with this operation 18,000 plus 7 into 1500. I have to calculate this with the help of 500. So it's just multiplying it with 3 and adding it after multiplying it by 7 or with 7. So next part is with this row, because we're not going to be changing really or making any changes to this one. We have we're going to be writing it as it is, which is 1 0 1 0 0 0, and this is 600. Okay. Now then we have this empty row where you need to again convert the value. So R2 minus R1. Oh no, this is going to be R2. Sorry, R3, not R1. It's going to be R3 because that is our pivot row. All the functions have to be performed with this row. You can't really perform it with some other row. So it's R2. Again, you have R2 as 0 minus R3 is 0, so you get 0 here. Now you have 3 minus 3, you have 0. And minus 2 minus R3 is actually 5, so it's minus, and a minus is plus 5. So 5 minus 2, you get 3. And this will be 0, so R2 is 1, so anything subtracted with 0, you get the same answer, 1. And then again you have 0, and a minus R3 is minus 1, so minus 1 here over the distance. And 0 minus 0 is again 0. So now, as you can see, this is minus 1. So minus 1. And the last I have R2 minus R3 is 2415. You get 900. So you get about 900. Let me just revise if any miscalculation. As you can see, this is 1 minus 0 is 1 is t, and then this is with R2 minus 1 is minus 1, and then we have R2 0, and then this is okay. Now as you can see, we have again gotten another negative value. Now we need to finish this negative value as well. So I have to make a table at the top, and I have to delete the remaining information. Already know the values of the constraints, so we just remake them. Okay, so we have to perform certain function on these variables to, again, consider pivot, column, and a row. So now this is going to be the main column S, and out of that, the lowest ratio we can have of 300, because 600 by 1, the text ratio gives us 600, and this gives us 300. So naturally, we're going to be selecting this. So for this now, it means that we have to perform certain function to make it 0. What kind of function would that be? So you multiply row 4 by 3 or 4, and this is going to be added by 5 or 2 to make it 0, because 5 into 3 is 15, and minus 15 plus 15 gives you 0. And this again, to make this as 0, we have again 5 minus 5, so we have 3 R3 plus 5 R2, because again we have exactly the same values. This remains untouched, and this now multiplied by 3 R1, and then you have minus R2, and this gives you 0. So this is going to be 3 minus 3, 0. Now I have to draw the table, so let me just see if I can maybe make it here as X, Y, S, T, U, P, and again repeat the same here as X, T, Y. Now since this is okay, so now this T will be replaced, because now this is the pivot row and the column, so we're going to be replacing it with next to the first two variables that we had, so X, Y, and then we have S. So I'm going to be writing as S and X, S, Y, and then we have R4, which is P. So this is row 1, row 2, row 3, and this is row 4. And since I'm going to be writing the pivot values first, because they are not changed, 0, 0, 3, 1, minus 1, and 0, and the values are, corresponding to the value is 900. Okay, it's not a straight line, like this. 1, minus 1, and 0. Okay. So now let us just move on to the equation where we have. So this is 0, and so we begin with this one first, because okay, so we have minus 5 and multiplied by 3, so we have minus, so this is the S part. So now we convert it into 0, because this is minus 15 plus 15, and it gives you 0. Next, we perform this operation uniformly on all the values across the rows, and so this is 3 R4. So for this row, this is 0 and plus row 2. So this is 0 plus 0 actually. So we are going to be getting 0 here. And again, now we have 0 plus 0. So again, we have a 0 here, because these values can't be, they can't acquire any value with 0 as their main number, which is a constant in this case. So considering this now row 3, or maybe just, okay, let me just complete this. So over here now I have 0, and this is, so 3 into 0, 0, plus 5 row 2. So plus 5, so this is going to be 5 in this case. It's going to be 5, I write 5 here. Now see, this is 7, this is 3, so 3 into 7 is 21, and minus 1 into 5 is minus 5. So 21 minus 5 will give you 16, and 3 into R4 is 9, minus 5 into 0 is 0, so it's going to be 9. Very good, 9. So now considering R3, we have 3R3. So this is 0 plus 5R2. Again 0, so we have 0 here. Then 9, 3R3, which is 9, plus 5R2, which is 0, so we have 9. And this is going to be 0 because this automatically becomes 0 because you multiply by the same operations. It's minus 15 and this is going to be 15, so cancel out. And this is 0 into 3 is 0 plus 5, so this is 5, right? And this is again minus 1, so it's 3 into R3, so this is 0, okay, let me just confirm, this is 0 and plus 5, so this is 5, and this is 1 into 3 and plus 5 into minus, so this is minus 5, so this is 3 minus 5, and you get minus 2 here, minus 2. And this is 0, so this is going to be 0. Okay. Now the top row is left. We see that this is 3R1. So 3 minus 0 is 3. This is 0 minus 0. 3R1 minus R2. So it's giving you 0, so you just write 0 here. And this will be again 3 minus, this is going to be 0. This will be 0 minus R2, which is minus 1 in this case. This is minus 1. And so now you have 0 minus, this is plus 1. So now we have it, plus 1. And this will be 0, and it's going to be 0. Now, the values which we are going to be having here is, again, performing the same function here. We multiply 28,500 by 3 and add by, 5 times of 1,500. So let's just 28,500 into 3. And you get 85,500. And let me just see, and 1,500 by plus 900, so it's 900 into 5 is, oh no, it's not 1,500, is actually 900, because it's R2, so it's 45, so 85,500 plus 45, no, this is something, oh, this is 28,500 into 3, and 5, 9, That's 85,500. Okay, so the value that we get is 90,000. And what we have done is to just multiply it with 3. And since this is R2, so we are going to be taking 900, which is about 1,500. So we're not going to take this one, we're going to be multiplying it with 5. So we get 4,500. So 85,500 plus 4,500, you get 90,000 here. About this one, again, we're going to perform a similar operation. 3 times of this plus 4,500. So now, again, we have into 3 plus 4,500. So we have 9,000 approximate. And as you can see, this is 3, so it's 3 into R1 is 600, so it's 1,800, and minus R2 is 900, so 1,800 minus 900, we get 900. So now our simplex table in this way is complete, because now we have all the positive values, as you can see. Now we need to find out what is the value of P in this case, assuming that all the other variables are 0. And okay, so I'm just going to be maybe drawing a little line for the working here, because I'll have to rub eventually. So now for P is equal to 90,000 by 9, and you get 10,000. Okay, and for X, it's going to be 900, assuming that the value is as 0, because we do know that there's an assumption that X is greater than or equal to 0, Y is greater than or equal to 0. So we can have X and as certain value, and then Y we can have as 0, or you can just keep one thing having a constant value, and the others you can just place it as equal to 0, so that is the way we perform the the function for linear programming, and especially to find out the maximized constraints. In this case, it's going to be 3, so we have X equal to 300. Then what is going to be the value of Y in this case can be equal to 0, because now in this equation we have Y, so what can we have? Y equal to 9,000 by 9, and you can have equal to 1,000. So Y in this case is 1,000, X is 300, P is 10,000. So we also need to find out the value of S, because in the initial constraint, as you can remember, that we had to give some value to S, and this, since we have this, and this, we need to find out the value of S as well, which is lying on the other side, the descriptive side of the column. So 900 divided by 3. So you have, for S, you can have S is equal to 900 divided by 3. So you have 300. So that means for the initial satisfaction of the constraint, we had X plus S equal to 600. That means that we have 300 plus 300 equal to 600. That basically satisfies the equation. Now, also we need to draw the graph for constraint maximization. We already had the equations with us. So let me just rough this up. Okay, let me just say that all the other variables like t and u are equal to 0 in this case. So when we draw the graph, actually, the feasibility region is basically that region which can give us the value that is, just below the maximized, variables. For this, we already have the equations with us. Let me just get back to the equation. The equation was in our, in this case, was 2x plus 3y is equal to 3,600. It was 2x plus 3y is equal to 3600. So now if you again keep one variable as 0, let's suppose just 0, okay? So 3y, so y in this case, if x is equal to 0, then y is equal to 3600 by 3, right? So 3 ones are 3, this is going to be 1200. So we can have a 1200 value here, 1200. This is 0, 0 where all the coordinates are, in this case x, y are 0. Now similarly for constraint 1, we can have the value of x by keeping y as 0. So now x is equal to 36 by 2. So it's going to be 2, ones are 2, 2, 8, 1800. So we can have as 1800 here, 1800 as x. Now similarly we have the second constraint, and I have to rub the remaining information. The remaining information states that constraint was about the value of this 25x and 15y is 22,500. So it was basically 5. And let me just write the other constraint as well. This is 5x plus 3y is equal to 4,500. So then in this case, as you can see that if we keep x is equal to 0, then 45 by 3 y is 3, ones are 3, and so 1500 basically. So y is 1500. Similarly, keeping y is equal to 0, x is equal to 45 by 5. So x will be 900. So now the other line that is half approximately here is going to be 900. And in this case, y is above. So now we're going to be, so this is 18, this is 1500, sorry. So now we just draw the maximize constraint. This is the first constraint we have. And the second constraint would be somewhat, with 900 of, and we have somewhat in the second situation we have x as 1200 and sorry, y as 1200 and x as 1800. Okay. Now you should remember that this line is the maximum that can give you the constraint for each coordinate. Okay. But when we want to draw the feasibility equation in the form of a graph, we have 12 and in the same we have 18. So now let me just draw it here. Okay. And in the next I have 15 to 9. So somewhat here. And the feasibility region would be like somewhere here. So first the coordinate would be 0 for all. Then we have the feasibility constraint here and these points. And this is the intersecting point. So according to the maximize constraints that we have, we had x as 600 and we had y calculated as 1000. So 1000 and 600 will be somewhere along this intersection. Okay, so it's going to be 600 and this is going to be 1000 and half of that. Now this is 600 and we have 1000. Sorry, this is 300 because 600 is when we assume that s is 0 or that other coordinate is 0, so we have 600 for the second situation, but this is third one, which is 300 to 1000. But now if I convert to 300, maybe this is, in this case this is 0, so at this value there will be no y, okay? So that means that I have to draw it to, 300. This is going to be 300, this is going to be 300, okay. For 600, okay. So for 600, I have to assume that now this lies between 300 and 900. So it's going to be somewhere here. And either I can assume that this is 0, or if I want to approach a value which is how long can I touch this line. If I extend this, okay, here. So now you can know that between this and this will, if you just draw it to the scale, this part would come about approximately half of this, and it's going to be 500. So y will be 500 in this case, and for x is equal to 600, so we can draw the coordinates. And this all will be your, you can, this is the feasibility region, but you can basically have this as marked and this as marked separately. So this is basically constraint maximization, feasibility region. This highlighted as this, and now we revert back. You can just do some other examples and questions because it is a very time-consuming portion. I would recommend that the book should be used by Stefan, Waner, and Stephen Costinoble, and the book's name is Finite or Finite Mathematics by Engaged Learning, and I would recommend the latest edition in this case. And you can just do the examples, and then you can just simply revert to the exercise. You can just read upon the examples and then try to do the exercise for section. This is chapter 5 of linear programming, and this is section 5.3. Okay, and I thank you for your time, class. Let's just see you next week. Hi, this is your instructor. I'm going to be teaching you about the minimization problems of simplex method. In the last lecture, we did the maximization problem, and today we are going to be doing it from a specialized example. But before that, I would like to introduce the concept that for maximization, actually we had the profit function, which is actually the constraint where we have, it could be, profit could be, sales minus cost. So that means that profit is basically, if sales are, let's suppose 0, so that means that P could be equal to minus C. So when we talk about minimization, it means that cost has to be lowered. So that is basically the central idea, that if we need to minimize cost, that means that we can maximize our profit, because if this thing is low, that means we can have the maximum profit. So therefore we can actually keep P is equal to minus C for simplicity, and the concept is that for minimization problems we can actually do maximization of P, so that P is maximized and C at the same time would be minimized. Now, for instance, I say that C is some function minus 10x and a minus 30y, or it could be plus 30y, for instance. And we can say that x is greater than or equal to 0 and y is also greater than or equal to 0 at this, in this particular objective function. This is basically our objective function for minimization problems. Now, if I assume that P is equal to some value minus C because of this central equation, that means that if I increase P, that means that C would actually be going down. Now, how is it possible? Because, see, if for instance, C is equal to, let's say, minus 12. C is equal to 12, or it could be the central number, then P is equal to minus C or equal to minus 12 in this case, right? Because it is minus C. Now, if I want to increase P, so I could be writing it like minus 10, because minus 10 is greater than minus 12 in this case. Now, if this is reduced from minus 12 to minus 10, that means C is reduced from 12 to 10. This means that when C goes down, when C would go down, P would be going up. That is the central idea of minimization constraints. And we are going to be following the same pattern that we did in the last question. I'm not going to be repeating the entire, working process in this lecture, but the idea how to differentiate between the maximization problem and minimization is, now we are going to convert the minimization into maximization, because since this is a minimization function, so we keep reducing C till we can minimize C to the lowest level. And then, since I told you that the principle is that when C keeps going down, P keeps going up, so we can maximize P instead of actually minimizing C. So we can say simply that the minimization of C is, even if it is the requirement, the main focus would be to maximize the profit. So we are going to convert this minimization into maximization problem like this. And any question, for instance, deals with purchasing orders, especially, then you want to actually have the asset or purchase of any furniture or purchase of any product. For instance, you need in a classroom we need to have PCs. So for that we would like to have the lowest quotation available. So we want to minimize our cost, and that minimization would again have the maximized effect in profit. So our main focus again would be maximization of profit. We are just going to be having negative signs for profit function, and then that means that we are going to be, instead of this, now we are going to be having, so P is equal to minus C, so minus C is equal to, then it's going to be 10x minus 30y. So that means that this would, when goes to the other side, is going to be P again will be positive. This is going to be minus 10x and plus 30y and plus P. So I'm sorry, it's not visible because of the thing. This marker is not, ink has dried up. Let me just rewrite this: minus 10x plus 30y plus P. So again, we will have those surplus variables that we have S, T, U, and P, and we can keep them as 0, other than the variables that we have. So it's like, if it has X value, for instance, what we did was X, Y, S, T, U, and P. So if we have an S, so we can have an S. So in a diagonal fashion, now again, for T, we can have this 0 and we can have 1 and then 0 elsewhere, and then we can have U, 1, and then, but since now this is a minimization function, so probably we could be having maybe negative values for especially the P is going to remain 1 positive because P has not changed, because now we are going to equate this function equal to 0. So therefore it moves to the other side. So now we can have maybe some negative values here, but usually the central focus is on the objective function, and that will change the signs because we are going to be multiplying it with C. So now let's just move on to the book, because this example is a long one. So I would just like to save time on this and work through the example which is solved for you people. And I've already told you that this is a very good book, and this is by Stefan Waner and Stephen Costinoble, and the book's name is Finite Mathematics by Cengage Learning. So see, now the question before us is that you are in charge of ordering furniture. Like I gave you an example that we have, to purchase some asset or some kind of some stationery or any administrative items for administrative functions and normal operations of the business. We have tables, chairs, and computer desks. Wall-to-wall furniture, so this is WWF, and it's not World Wrestling. So it's just basically wall-to-wall furniture. And then we have the Acme Furniture AF, which is offering a package of 10 tables, 50 chairs. So basically now we have two things. First of all, we have wall-to-wall furniture. We are going to keep it as X. We are not going to be keeping table as X. The reason is because now we have table in many offered from various companies. Therefore, then there'll be X1, X2, and X3 in order to minimize the confusion aspects. We will just keep this as X, so we can have at least one X, and then again we can have one Y, and then again we can have X and Y. So if we have wall-to-wall furniture as X, then 200 X, right? And then we have Acme Furniture, 10 tables again, then we can have 10X in the next equation. We can have various constraints in this case. Now you can see that what they're looking for is that for 2000, that means that now we can have this value as the cost inculcated in the cost function, but for that we also have to consider the constraints as 200, 500, and 300 computer desks. So at least means that greater than or equal to. So that the first equation would be like, we have 500 chairs, so it's going to be for WWF, so it's going to be 500, 20x, and then we have 10 of Y, because now we have Acme as Y. So then we have 10 of Y and 20 of X. So 20x plus 10Y will be actually, now at least, it means that we need at least this much, is greater than or equal to 200, right? And then we have again 25x, which is 25 chairs, and 50 chairs again. So it's going to be 25x plus 50y greater than or equal to 500. But then we have computers, so again it's going to be 18x plus 24y greater than or equal to 300 computer desks. And then again we have the objective function along with the constraints. So now how many packages should you order from each company to minimize your cost? So that means that now cost function shall have both the values for 2000 and 3000, x and y for desks, and from this company and from that company, whereas it's offering a package for 3000. So now this is, since we have kept this as x, so we're going to have 2000x and 3000y, and which will be equal to c, so we can have as minus c for the maximum profit. Now let's just look at the equation here. C, we have c as 2000x and 3000y, which is equal to c, but now we would be maximizing into p, so we are going to be actually shifting the focus. Now the other constraints are basically like I told you, 20x plus 10y greater than or equal to 200, 25x and 50y greater than or equal to 500, and then 18 plus 24 greater than 300. And we assume that x and y are greater than or equal to 0. Don't want to take any negative values here. And before that also we have to simplify like we did in the last lecture. If you have gone over the previous one, you will see that if there's a common divisor, then we can just simply divide them by 5 here, 5, 10, and we can have 100. So see, if again we can divide it by, so it's like 5 1s are 5, so we can have x, 5 2s are 10, is going to be 2, and then 5 20s are 100, then it's going to be 20. So this is divisible by 2, and then 10, 5, and again we have 100. But this is again divisible, so we can have again 5, 10 divided by 5, and again we can have, since this was 5 1s are 5 because this was already 5, so 5 divided by 5 is 1, so we can have 1 here, and then since we had 100 here, so we can just multiply by 20 and we can have 100. So this is, and then the last one is divisible by 3, so we can have 6, 8, and again we have, as you can see, 100. So 3 into 100 is 300. So now again, since we have, this was 6 and this was 8, so we can multiply, divide it by 3, because this was, can we have it by 3 or not, or 5, can be divided by 3 or 6, basically. Yes, 6, sorry. So it's going to be 3, first of all dividing it by 3, so it's 3, 6, 3, 6 are 18, 3, 8 are 24, and 3 into 100 times. But then we can then further divide it by 6 and then 3. So again we can have, or 2, as you may have. Let's just see that this is 18 by 6, and then again, since this was, this was first of all divided by 3, then we have 6, and then we can again have divided by 2, so we can have 3, and then we can have again 4, since we already had 8 here, and then since we had 100 here, so we can multiply it by 50 with 2, so we can have 100 here. And then we just simply simplify this thing to give us these simplified constraints. Now since I told you that P is equal to minus C, we can just simply change signs here. So it's going to be minus 2000 and minus 3000. Now we're going to be making the table. As I told you that there are surplus variables. With us, we're going to be having x, y, s, t, u, p, and then we're going to have x. Adjacent to that, we can have again s, t, u, and then p under the line. Now I told you that we can have minus sign here. Since we have in the previous lecture I discussed that we had a less than strain, so that means basically that we can add something to that in order to make it equal to that, because we were having a lesser than or equal to value here. But now in this case we have, as you can see, greater than, so that means we have to subtract something from this equation in order to make it at least equal to this value. So if I say that 3 is greater than 2, so that means that we have to subtract something from 3 in order to reach at 2. So now in this case, you can just consider this as 3, and this is 2. And you can have to subtract something from it to make it equal to this constraint. So it's minus s, minus t, minus u, and p, positive, because that is an objective function. Excuse me. Now the starred rows here basically show us the surplus function that we have to replace with the variables. And if you look at this equation, first one, as I told you in the previous lecture, we were trying to see the maximum negative value over here. I'm going to be, having these values equal to 0, as you can see from this value. So we have to, since have both the values equal to 0. So we start with this value, that is the initial. And we have to see the test, basically the ratio test has to be the least value in this case. Now, we are taking, in this case, the first column. In the previous example, we had the max negative value because that was the lowest value. In this case, we take this value was less than 3000 in this case, but we also need to zero this entire row because this is going to be our pivot row in this case, and the pivot column. Now you have to divide all these numbers by their respective, values in this column. So these numbers will be divided by these values: 20 by 2, 20 by 1, and 50 by 3. So if you can see that in the numerator, is already very large here, and the denominator cannot sufficiently be reducing the value as compared to the value which 2 can maybe reduce, because 20 by 2 will give you 10, and 20 by 1 will give you 20, and 50 by 3 will be a very large value, because it's going to be, it's going to be again going way above, because it's going to be 3, and then it's going to be way more than that. So we have, this value as 2, because this is the lowest value. So even though if this is, like let's suppose 20 is the largest here, because we can have, 3 ones are 3 times, and then we can have, see, 6 are 18, so 16 point something, but this value is, 10. So it is again lesser than 3 in this case. So we can have this as the central value, and we can just simply highlight this as under here. Now we can just rewrite this whole equation, the whole arrangement in this case, as 2, 1, minus 1, because instead of s we have minus 1, but the remaining will be 0, and again in this value we have 1, 2, 0, minus 1, and then 0, 0, and then this 3, 4, and 0, 0, minus 1, and 0, and these values will be subtracted, so missing in this last equation, so we'll just write 0 instead, and then we have plus 1 in this case, and then this initial tableau has these positive values. So the lowest value, and then the row in which this lies is the first row, which is R1 in this case. Now what do we have to do to basically make this as 0 in this case? We have to subtract something from this to make it 0. So what do we subtract? We multiply this with 1000. So it's going to be R4. So you just number the rows first, 1, 2, 3, 4. So it's going to be R4 minus 1000 of R1. And you have to make sure that all equations will be involving or including this row 1, because it's our pivot row and column. So it's going to be 1000 R1. And this will give you, again, 0 value. As you can see, this is 0 value here. And you always write the function that you're going to perform in the next table, in this table, right? Then the next, we have to make this entire row, as per the condition that has been imposed, written here. So now, for 3000 now, when you have to multiply, you have to subtract something by multiplying 1000. So it's going to be, so this is 3000, and it's going to be minus 1000, because now this is 1000 of R1. So you get 2000 here, right? And then this is 0, and minus will be plus, right? So it's going to be plus, again, 1000, or so you can see that this is 1000. Over here it's going to be the same 0, 0 minus 0, this will be 0 minus 0, and this will be 1 minus 0, so it's going to be 1. Coming to the next, then we have, as you can see, this is row 3. We already, have this value as 3, so which is not, having anything common with the first row. We multiply this with 2, and we multiply this with 3, so that 6 can be subtracted with 6. So you can write that this is R3 into 2, or 2R3 minus 3R2, or it could be, 3R1, because this is the first row, so it's going to be 2R3, 6 minus 3R1, which is 6. So you have 6 minus 6 equal to 0 here in this row. Now then, we have again the same condition, 8 minus 3. We have 5 here. We have 0 minus, and minus 3 is plus 3. Then we have 0. Then we have 2R3. So it's going to be not like, so it's going to be 2, so it's minus 2. And then minus 0, so it's going to be again minus 2. Then 0 minus 0 will give you 0 again. And same procedure. Now, if you see that how you are supposed to make this as 0 is just simply multiplying it with 2, so it's going to be 2R2 minus R1. So it's going to be 2 minus 2 is 0, And you can just repeat this process till the end. So it's going to be, you know, zero, 2, minus 2, 0, and then again 2 is 4, minus 1 is 3, 0, minus and minus will give you a plus. So this is as it is minus R1. So minus and minus 1 is plus 1. This is again 2 into minus 1 is minus 2. And this is minus 0, so it's going to be as minus 2, and this both will be 0. So we have completed basically the first step now. Always remember that once you have highlighted the pivot column, and you have to change the variable, which is the surplus variable, into x. You have to convert this into x. So we wrote this as x instead of s. All right. Again, we have to perform the same function. Now we have when we did this function, we had 2000, 1000, and this keeps going on. Again, we have to come to the next lowest ratio, where we can, lowest test ratio by dividing all the numbers. We have to ignore basically the negative values here. We can't have those as our ratio. But now, since this is the first column has already been reduced to 0, now we see what is the value which is next. Now, if you see that once you divide it by 1, it will give you 20. Can't accept that. If you even divide it by 3, it will not give you the lowest ratio. If you divide it by 5, it gives you 8. And if you divide it by 20 by 3, it gives you 6. So we can accept this number now. And this will be the number which we'll have, and this will be the column that we are going to be addressing first. So in this case, we have to make this 0. And we have to repeat the entire procedure that I explained to you in the previous lecture. How you're supposed to do it, for instance, again, I'll just be explaining the first part of this, and then you can just follow up on the rest of the example, which is already given in the book. So for instance, if you have, let's suppose 2000, because I had to go for the lowest test ratio. And that is the easiest way to find, because this is, anything, just see that, if you divide any number, the lowest number in this, because both are positive and none of them is negative, so we can't take the maximum negative value. So then we have to consider, first of all, which will give you the lowest test ratio. And this is the only number at this time that will give you the lowest test ratio. Now, then this is 2000, then again you have to multiply it with 3, and then you have to multiply it with, again 2000 to subtract it from this value. So multiplying this row 4, so you're going to be multiplying it with 3 to make it 6000, and multiplying it by 2000 to make it 6000. So you can just subtract from R4 after multiplying 3. So 3 R4 minus 2000 into R2. As you can see, this is the value. So, and then you can perform the main functions. This will give you 0 in this case, right? So now again, you can just simply fill in the values. Again, now you have here, which is you have to also make these 0 and not the other ones. First of all, you just handle all these 0, but once you are acting upon one number to make it 0, then you have to consider the entire row for that same function. And always remember that since we have these functions in this column, these are also going to be worked upon. So for instance, if I had 2R2 minus R1 here, so it's going to be like this is 20, because we have the constraint. If you see the beginning, we always have the constraint here. These are the constraint 20, 20, and 50, which are here. So it's going to be, now since we had written this function, so we also have to perform the operation. So it's 40 minus R1, which was 20, so we have 20 here. This is 20. And this was written as this because this was a pivot column and row. And this will remain the same. And then from 50 you had, so it's 2R3, so it was 100 minus 3R1, which was 60. So 100 minus 60, you get 40. So similarly, you're going to be performing the functions, and you can't ignore these values as well. And similarly, you had this 3R4 minus 2000 R2, which was, it's going to be reflected in the next column. But how did you have this? So it's R4 minus 1000 R1. This was R4, which is already 0, and minus 1000 R1, which was minus, so it's going to be 20,000. So you have 20,000 minus 20,000 really. Again, you can just simply go to the next table. Now again, you can just simply divide these values to find out what each will give you. So it's going to be 40 by 6, 6 6 are 36. So you can have a value 4 again, something, and then we can have further divided by, and then you have the decimal value. But if you see 20 and then 6 point something again here, and then you can just simply see 20 by 10, and you can have 20 by 4 as well, so it's 5, which is again lower than 6 and 6 point something here and 6 point something here. But if you just divide 2 by 4, you get 5 something, but if you divide 20 by 10, you get around about 2. So this is the lowest value, so you're going to pick this column T. And at the same time, you have to change the value here because this is Y column, and we change it into Y. But since we already had STU, so now this U has to be converted later on into, so this was, S was changed, T was changed into Y, and then from here you have U and you can have P, and then this will be changed again into respective value T. Because this value is the column, we can't have S really, because had we considered this column, then we would have had S here. But since we have chosen this column, so instead of S, now we're going to be writing T here. So we put a star and then we can just replace it by T. It basically means that you have to replace this value. Now you can just take it as the pivot column and then again perform the same function as, this is the last row, which is R4, and we have to make it 0. So you have to multiply this by some value to make it 4,000. So when you divide it by 10, so you get 400. So you multiply it by 400, so it's going to be R4 minus 400 into R3 to make it 0. So again, repeating the same procedure for all the rows except for this row. Then you have, if you can see, how did we get this value? So now, minus 20,000, this was basically 3 into R4, which is 60,000 minus, again, then we have 2,000 into R2. This was 60 minus 40,000, and this was minus 100,000. But then now again we are going to be performing the function of R4, which is minus 100,000 minus 400 into R3. See, this is R3 is, so it's going to be 8,000. So it's going to be minus 100,000 and minus 8,000 will give you minus 108,000, as you can see. But we have to simplify this equation, see, because this is becoming very complicated for us, since now performing these functions has again yielded a negative value in this case. So we are going to be dividing it by respective numbers to actually at least minimize and simplify the values, and this will be done in phase 2. So it's going to be 3, when you divide by 3 you get minus 200, 3 6, and you get 3 600, and then 1, at least you get P1, and then you can just simply divide it by 3 as well, and you get the respective value of 36,000 here. So now if you can see this, again repeating the procedure here, we can perform the function as 30 by 5, you get 6 here, negative values you're not going to be considering, this is a too large a number, again 40 by 5, 8, this was 6 is 8, this is too large, again this is again negative, we can't consider this. But then this is, this was 6, this was 8, and this is 5. And this is again we can have by t, but already we have a 0 here, so we're not going to be considering this value, but this is the negative value, so we consider the negative value first. And we can have 2 here as the main pivot, part of the pivot column, because this is already 0 here, so we can't consider this. Although it would have yielded us the lowest value, but we can't consider this because the negative has to be finished first. Again, we're going to be performing the function as R4 and because this is main minus 200, and then we have to add something to it to make it plus 200 to cancel out the effect and make it 0. So you have to multiply it by 100, and then minus 36,000 plus 100 R3, which is plus 1000. So it's going to be minus 35,000, and all the values will be will be changed for the particular column into 0, except for this T row. And then now, as you can see now, since in the previous one we have T, we changed it into T, but then in this we have S. So for the operation number 2, now we are going to be changing the T into S. Okay. So now this is known as the phase 2, and you have to make sure to read this value. There's a short note in the. This is basically almost we're done here, because what we needed is basically that x, y should be primarily 0, and we've been successful in doing that, and then the negative value had to be finished, so we resorted to the third step again in the second procedure. Now what do we need to find out? The value of x, which is 50 by 5, we get 10. The value of y, which is 50 by 10, which is 5, and again, this is 10, this is 5, and then you can have s as 5 as well. And s can be here also, but since now we are replacing the s here, so now we can have s as 5. And if we had t, then we would have chosen it as 2, but the last has to be considered first. So if you see that s is considered as 5 and t has been considered, and u has been considered as 0 going on, this is the last table that we consider in this case. So to make all 3 into 0, and then this is the main value that we take, because this is the pivot value. Okay, so now how are you supposed to interpret this part? Since our C is basically P was minus C, minus 35,000, as you can see here, this was minus 35,000. So C is going to be 35,000. That means that whatever that we do, it has to be within the range of $35,000, and this should be the minimum cost for us. And we buy 10 packages from WWF as X and 5 from Acme Furniture, but they have asked you to read this stuff, and the main portion that you have to read is when to switch to phase 2, quality constraints, and just go on with this so that your concepts can be tied up together from with the previous lecture that we did. I thank you. Let's just have a rundown with this to have with an equality constraint. And if you have any issues, then you can just come back to me. See you next week, guys. Thank you very much.